The video showcases a common 3D printing technology, fused deposition modeling, FDM, which creates three-dimensional objects by heating and extruding thermoplastic filament layer by layer. Temperature control during printing is crucial, as it affects the material's flow, adhesion, and the bond strength between layers. Using a thermal imager to monitor the temperature distribution of various parts of the printer and the printed product provides reliable temperature information to the staff, helping to improve the quality and performance of the printed products. The temperature of the heating module and nozzle of a 3D printer needs to remain stable during operation. Fluctuations can lead to uneven melting of the printing material, affecting the quality and strength of the print. Using an infrared thermal imager, temperatures of the entire heating module and nozzle can be collected non-invasively, automatically pinpointing the highest temperature points. This efficient and comprehensive detection allows for real-time monitoring of potential issues like short circuits in the heating module, poor contacts, and clogs in the nozzle. Any abnormal temperatures can trigger audio-visual alarms, alerting staff to intervene promptly. Thermal video can generate a time temperature curve, helping R&D personnel understand the temperature variation during the printing process, thereby mastering the processing technology of new materials. FOTRIC's infrared thermal imager can be used to observe the temperature distribution of the printed object in the material stacking state, understand its heating condition, and detect issues like local overheating or uneven material solidification. Additionally, using the line temperature distribution curve function of the thermal imager to test the temperature distribution of the printer's vertical extrusion can aid R&D personnel in quickly understanding the material's cooling rate, thereby adjusting the printing speed or altering the print thickness to improve print quality in that area.